I'm Tiera Fletcher.
And I'm Myron Fletcher.
We are rocket scientists.
And today we'll be answering your questions from Twitter. This is Rocket Support.
At Baitmaster OG, why do rocket ships launch straight up instead of at an angle like a plane?
It's because the way thrust is propelled out of rockets. If you launch the rocket sideways, you wouldn't have the counteraction of the ground being able to push from.
The hardest part about launching a rocket is truly getting off the ground. So that's when you're experiencing your greatest amount of gravity, and that's when you need the greatest amount of thrust.
A rocket takes off straight like this, but once it's in the air, we can use thrust vector controls to turn the rocket in any direction that we would like for it to go in. So it doesn't go straight out of the Earth's atmosphere like this. It actually comes in at an inclination like this. Rotations are like this, they're not like this. And so in order to get out of a rotation, it's better to go with the rotation than trying to go through the rotation. And so therefore, rockets will have an inclination to go out sideways versus straight forward.
At Polygowski66 asks, what is the skinny on Mr. Musk's new rocket engine? So the Raptor 2 engine produces about 510,000 pounds of thrust, and this is actually comparable to the RS-25 engines that are used for the Space Launch System. They will be utilized for the Starship. The Starship is a super heavy launch vehicle produced by SpaceX, and I know that for Elon Musk, he has a huge goal of going to Mars. So the Starship would be the vehicle to achieve that goal for him. It's predicted to have about 33 of these rocket engines. So you're looking at about 17 million pounds of thrust that'll be produced from the Starship. So that's a major difference from the Space Launch System, which produces about 8.8 million pounds of thrust.
SLS only uses 4 engines, where Starship would use 33 engines. And so if they can figure out how to get all those engines to fire off at the same time, every time, they're going to have a very, very powerful rocket on their hands.
So the Starship could take the crown for the most powerful rocket in history. At Somebody Hello Lee, what are parts of a rocket? Well, a simple rocket consists of a structural system, which would include your nose cone and your fins, as well as a propulsive system, right? So a small engine that would go inside of a model rocket, for instance.
The reasons you have fins is because these fins causes the rocket to be stable. And so this fin actually causes downforce to take place.
Now, when you're talking about a more complex rocket, such as NASA's Space Launch System, you are looking at a propulsive system, but your propulsive system is going to include these solid rocket boosters here, which includes solid propellant.
And those solid rocket boosters might look familiar. They're actually from the Space Shuttle program, just a little bit modified. Another section has been added to them. And the solid rockets are important because they provide about 90% of the thrust needed to get Space Launch System off the ground.
But then you also have liquid propellant in the form of liquid hydrogen and liquid oxygen. But then here you're wondering, where would the astronauts or the payloads go? Inside of the Orion capsule. And that is where the Orion capsule sits. And together you have your Space Launch System. At Philip Ben asks, maybe a dumb question, but why are rocket engines that loud? What exactly is making that sound?
So the thrust that these rockets are throwing out is actually going past the speed of sound. And because it's going past the speed of sound, it creates these whiplashes, or known as shock waves. These shock waves then cause rumbles to happen and vibrations to take place. And all of this together creates the noise. And that's why it's so loud.
At Ian Vincent Scott asks, so what fuel is powering the rocket ship that NASA is sending to the moon? NASA's Space Launch System is using liquid hydrogen and liquid oxygen.
Now, very, very cold liquid, normally known as cryogenic, negative 423 degrees Fahrenheit for liquid hydrogen, and negative 297 degrees for liquid oxygen. When you combine those two, the fuel and the oxidizer, you get combustion, called thrust, and you get about 2 million pounds of thrust out of those systems. The solid rocket boosters are made of a proprietary material, and that material is a hard material that is lit together from the inside out, which creates thrust for those solid rocket boosters.
At The Physics Memes asks, how do rockets burn fuel in space if there isn't oxygen in space?
In the combustion chamber, you have the fuel and the oxygen. When they meet each other, that's called combustion. That combustion causes thrust. In order for combustion to take place, you need oxygen. A rocket actually has its own fuel and oxidizer on board. Even though there isn't oxygen in space, it brings its own oxygen source with it.
At D. Lucy asks, what makes a rocket a rocket? Is there a guideline? Does it need to go to space? A rocket is anything that is a structure with a propulsive system and a nose cone.
A prime example of a great rocket would be a firecracker. A firecracker is a rocket because it has a propulsion system.
At Mo Artwell asks, why build the other parts of a rocket ship if they are going to separate mid-air, and where do the remnants fall? Your powerful rockets that are heading into space, they are actually multi-stage. So once a stage is completely depleted of its fuel, you no longer need it. So these two particular solid rocket boosters, they're the first to fall off for the Space Launch System. And then you have the core stage, the liquid hydrogen and the liquid oxygen. Once those are completely depleted, you no longer need this entire core stage. Where do those pieces fall? Typically into the ocean.
Anything that's close to the coast was the best place to shoot off a rocket. Most parts that land into the ocean, there aren't reusable parts. But now they're actually landing those parts on space barges, which are reusable.
At DKUI, 23 asks, how do rockets land? Like, don't they just go straight up and down?
Yeah, there are a few companies right now that are using reusable rockets that are causing them to land back on the Earth. Blue Origin and SpaceX are two prime examples. Their rockets will launch off into the atmosphere, and then they'll send their payloads off into deep space, and then the actual booster parts will come back down to Earth safely, and they'll actually cause thrust to come out of the rocket right before it lands, causing it to slow down and give it a cushion. It's a very complicated process to make that happen. Very, very. It's like causing a pencil to land on its eraser.
At Real Mark Ridley, how do rockets get built? For large rockets such as the Space Launch System, it truly is a nationwide effort, and also even international, where it takes thousands of suppliers coming together in order to get this one rocket built.
You got to start at the component level, the parts that you can physically see and touch, and some that you can't physically see and touch. Those parts are built at suppliers all over America. Once they're tested, they're all shipped down to Michoud Assembly Facility in New Orleans. And in New Orleans, you have a group of test engineers and production engineers who actually put the parts together, and once they're put together, we then send it over to Stennis in Mississippi, where we actually hot fire the rocket. And that's where we run a full duration test with liquid hydrogen and liquid oxygen. Once that test is completed and the NASA engineers are happy, we then shoot it over to Kennedy Space Center. There we actually put it on a launch stand, and from there we actually cause the rocket to go into space. And those are the steps to how you build a rocket.
At Sid Think of asks, what will be the next huge revolutionary advancement in rocket propulsion? Warp drive, nuclear propulsion? Go ahead, propulsion guy.
We currently have nuclear propulsion systems. Nuclear propulsion sounds great, but let's just wait until we start shooting a bunch of nukes in the air and figure out if other countries don't get mad about it. So based on the theoretical limits that we've studied so far, there is a possibility that one day we might be able to travel at light speed. We possibly can with fusion technology. So there are technologies that are out there that are currently still being developed. They're on very small scales right now, but one day they'll be commercially available and we might have warp drive in our own lifetime. One thing that's critical here that you have to counter for is human factors. The body can only withstand so much gravity. And so when you start exerting that amount of pressure and that amount of energy on the body, the technologies might be there to propel us to go light speed, but can our bodies withstand that speed?
That is an interesting handle. I'm gonna try. At Divan Remortal, can rockets be used to intercept asteroids and redirect them? NASA actually completed a mission called DART.
Double Asteroid Redirection Test.
To test and see if we can actually defend our planet. And we successfully did.
When that probe hit the asteroid, it actually caused the momentum to change of that asteroid, which caused its orbit to slow down by 33 minutes.
There could come a day where a super huge asteroid comes our way. So now we can use all of the momentum transfer data so we can figure out how big that spacecraft needs to be, how fast it needs to go, compared to whatever asteroid is coming our way. At Hula Gangster asks, what's the difference between rockets and ballistic missiles? Rockets and ballistic missiles are built very similarly. The only difference is the payload.
The different payloads is one is carrying humans and the other one is carrying warheads.
At Blakeham Band, what is harder, rocket science or brain surgery?
Coming from a rocket scientist, I think it's rocket science.
Listen, brain surgery is difficult. You are dealing with one of the most important organs of the human body. So just 1 small centimeter, or even smaller than that, you can literally disable someone.
You know, with rocket science, if you're off by 1 centimeter, by 1 micrometer, you can cause catastrophic failures to take place.
Yeah, I do rocket science every day, and it is quite difficult, so I just can't choose between the two. They're both just hard. At Shay Payne 14 asks, like, why can't I just be be like Jimmy Neutron and just build rockets in my backyard and stuff.
Well, actually you can. There's an entire society, National Association of Rocketry, all around the United States. Amateurs are building rockets in their backyards, and we ourselves, we actually build rockets in our backyard all the time. Now, if the rocket happens to go above 3,218 feet, you're gonna have to get a regulatory agreement from the NAR Society or these other societies to say that you can fly that rocket. Otherwise, you might interfere with somebody's passenger flight.
At T. Bieber Belieber asks, I'm confused. What's the difference between a spaceship, space shuttle, and a rocket?
A shuttle, for instance, is something that's going to carry humans into space and back down into Earth. That's why it's called a shuttle. It literally carries humans in and out. A spaceship could be used interchangeably with the space shuttle, but if you're talking about a specific spaceship, you're usually talking about something that's going in between different orbits.
A rocket is simply a structural body that you can launch. It has a propulsion system. So it can be your fireworks, or it could be the Space Launch System. At Noman Ali 7147, how do rockets or moon missions get back to Earth from the moon? Let's say you have a spacecraft orbiting the moon, then you reach a point where you want to return to Earth. You then need to understand what is the amount of thrust or what is the amount of drag that I have to overcome in order to escape this orbit.
When you come out of the moon's orbit, it has its own gravitational force. In order to come out of that orbit, you have to slingshot yourself out of that orbit. So you use thrust in order to slingshot out of the moon's orbit to get into Earth's orbit. So you go from a lunar orbit to a geosynchronous orbit is what we call it. And once you get into the geosynchronous orbit, you decrease your speed so that you can come back to Earth. You slow down a spacecraft by using reverse thrusters. Spacecrafts normally have thrusters on the front and the back. And so when you're going into these different orbits, you will actually fire those reverse thrusters to actually slow you down.
You then want to deploy parachutes so you can have as soft of a landing as possible. At Angel Yuki asks, how do rockets know exactly where they have to go?
Guidance, navigation, and control. And all those systems come in together, and that's called control torque. And that's also known as gimbaling.
The gimbals are located at the front of the engines here. These are RS-25 engines that are located for the Space Launch System. And by using gimbaling, we're able to slightly move those engines on the order of about 10 to 12 degrees. And we're able to slightly adjust the rocket in such a way to correct its trajectory as we see fit.
Just like a ship, right? A ship it's a really, really big object and has a little bitty rudder that causes that ship to steer left and right. It's the same way with the rocket. 320 feet tall and 10 degrees can cause a rocket to steer left and right.
At Mike Sparrow asks, who was Katherine Johnson? Katherine Johnson was an amazing woman, and she was one of the first African-American women to work for NASA. She was a mathematician. She was responsible for doing the trajectories for the Freedom 7 mission, as well as the Friendship 7 mission, as part of Project Mercury. And those were actually our first human flights for the United States of America. At Space Science 73 asks, so what is the coolest rocket launch ever? A little biased, but NASA's Space Launch System is the most powerful rocket ever launched in history, so it's my favorite. What about you, Myron?
I would say NASA's Space Launch System as well. The reason being, we had a very, very powerful rocket launch and take a capsule as far as we've ever sent it. We've never sent a capsule that are going to carry humans as far as we've sent that capsule. To me, that's the coolest thing that you can do as a rocket scientist.
At Alec the Destroyer asks, yo, how you become a rocket scientist?
So for us, it starts with the degree. You go to school to become an aerospace engineer. In this degree, you're going to have to go through calculus 1, calculus 2, calculus 3, differential equations, a lot of math. And then you have to have the science part, physics 1, physics 2. But then you go into orbital mechanics. You're going to have to study aerodynamics. You're going to have to study dynamics, statistics, statics. And then you're also going to study different things like propulsion, computer-aided design, and different fields like that with the aerospace engineering degree.
At Lionel Media asks, what was Operation Paperclip?
So Operation Paperclip was an intelligence operation that took place to get a bunch of German scientists over to the United States. We got to pick their brains, understand how they were building the V2 rocket.
One of the German scientists that we brought over was actually called Wernher von Braun, and he was the director of the Marshall Space Flight Center. Now, he was a visionary. He really wanted us to get to Mars, and so the Saturn V was a bit overly built. You can read more about it in the Mars Project, one of the books that he published in the 50s. But he was definitely one of the founding fathers of our space program. At Interrobang 2X, will humanity ever leave the solar system?
Really, really good question. So we've actually had spacecraft that actually have left our solar system, Voyager 1 and Voyager 2. Now, Voyager 1 and 2 were launched back in the 70s, and they just now made it outside of the solar system. So you can imagine putting humans on a rocket for 30, 40 years, how that'll turn out. But the possibility is definitely there.
Current propulsion technologies could expedite that 40 or 50-year journey, but it's still a long way to go, and those probes are out there learning more about that environment before we put a human into that space.
So those are all the questions for today.
Those were a lot of great questions, and if you're interested in learning more about rocket science, we definitely encourage you to pursue it.
Thanks for watching Rocket Support.